to, this is June 2018. Let me just screen share. Okay, June 2018, question 10. It says a learner investigates the relationship between volume and temperature of an enclosed gas. She records this. Name the law being investigated. What I really want to focus on here is the graph's gradient. Okay, like I said, that's usually the trick question or the tricky questions in this section. Maybe before you guys start that, we can just talk about some common gradients that they get. If you guys get a graph, this often gets given and was in the live worksheets as well. If you get that graph, and you have to work out the gradients. Now, obviously, P and V are inversely proportional. So if you want to draw a direct proportional graph, you have to draw P and 1 over V, or V and 1 over P, doesn't matter. If they ask you to work out the gradient and then do something with the gradient, okay, your first job is always to figure out what does the gradient mean. So pressure divided by 1 over volume. Okay, if you keep change flip, it would become that. And then just think to yourself, what would that equal to? So you've got this formula PV is equal to nRT. So if you have the gradient is equal to P times V, then the gradient is really equal to nRT, isn't it? And what they'll usually do next is they'll say to you, use that gradient and work something out. Like use the gradient and work out, I don't know, the number of moles of gas. So then you can go, okay, when you work with the gradient, I'll set it into there. Then they'll obviously have to give me the temperature, and then I can work out the moles. Okay, so this is something similar to that. This is actually quite a nice question. But they're giving you a graph of volume versus temperature. Okay, and remember that it would only be directly proportional if the temperature is in Kelvin on the axes. Okay, so you guys can answer, let's see. Actually, let's answer this whole question. I'll give you guys some time to do this, okay? Name the law being investigated when you compare volume and temperature. Write down an investigative question. 2 variables that need to be controlled. In every chem exam, and every physics and chem exam, there's always a prac question in. And gases is oftentimes a prac question because it's such a real life section that they can ask what are the variables, what do you need to keep constant, and stuff like that. Okay, so it's a good example to do. And then up to calculate the gradient, and then use your answer to calculate the number of moles. So that's a really nice question. Okay, so I'll just scroll up a bit. Okay, so this is June 2018, if you can get it in front of you. Okay, so the first question, name the law being investigated. Okay, so what law investigates the relationship between volume and temperature?
Charles' law.
Okay. Write down the investigative question for this. So always like, what is the relationship between independent and dependent? So what is the relation between the, and be careful, you have to say Kelvin temperature. So what's the relationship between the Kelvin temperature and the volume of gas, of a fixed amount of gas? If you're also keeping that constant, it's a good idea to work that in. So you'll see, sorry, it's very fuzzy. What's the relation between the volume occupied by an enclosed gas? They say enclosed gas. I would even say like a fixed amount of gas, but it means the same thing. And the temperature, this actually isn't completely right. We have to say Kelvin temperature, okay? Otherwise, I'm not going to mark it right. Then it says, write down 2 variables that need to be controlled. Okay, so because you're changing temperature and seeing how it affects volume, you need to keep pressure constant, and the amount of gas you need to keep constant. Okay, then from the results, what conclusion can the learners make? That volume is directly proportional to Kelvin temperature again, because you're getting the straight line graph. Just for interest's sake, because I saw that again in a paper yesterday, if they give you the graph but the temperature is in degrees Celsius, what do you call that relationship? Because you're not allowed to call it directly proportional unless it's a straight line through the origin. That relationship is called a linear relationship, if that ever comes up. Okay, so volume and temperature in, in degrees Celsius would still be, there would still be a relationship, but you just call it linear. It's not directly proportional. Okay, so in this case, the conclusion is that volume is directly proportional to Kelvin temperature. Name the apparatus used to measure the independent variable in this investigation. So this is my independent, so just a thermometer. Okay, calculate the gradient of the graph. Okay, so first of all, let's try and figure out what the gradient means. Okay, so volume divided by temperature. That's your gradient, okay? So if you look at your formula, PV is equal to nRT. And like you guys have seen from the worksheets, there's lots of variations of them dividing different things. All you have to do is just try and manipulate this formula and try and get it to look like that, and then see what it equals to. So I want to get V, so I'll get divide by T on both sides, okay, because this is what I'm looking for. So that cancels, obviously. Then PV over T is equal to NR. I want to get rid of the P though, because it's not part of it, so I'm going to divide by it, but then I need to divide by it on this side as well. So then the P cancels out, and then I literally just have V over T is equal to NR over P. So the gradient literally means, it's not something like nice or something that you can just write out in one word. It's literally just NR over P. So the mole time R divided by P. And that's obviously why they give you the pressure in 10.7, because they ask you, okay, first of all, let's work out the actual gradient. So just pick the nicest points that you can find. I'm literally just going to pick the last point and the first point. Okay, you might get something slightly different if you choose a different point, but there's a bit of leeway for this question, for this answer in a test always. So we'll go, the gradient is equal to, I'm going to say 80. Okay, so we are going to plug this into this formula. Okay, the PV equals nRT. So it's better to put volume into meters cubed. Okay, so because I'm working with this formula, volume has to be in meters cubed. So I'm going to divide. King Henry died a miserable death called measles, going from centi to meters. Okay, but centi cube. So you do normally divide by 100. Now you're going to divide by 100 cubed. So it's going to be tiny. Okay, so I'm going to go 80 minus 0. Even if you're picking the 0, you have to show that. Remember, gradient is the difference of something. Okay, and I'm going to just divide that whole thing by 100 cubed before I divide. Sorry, yeah? Sorry, I thought someone was asking. Okay, and then divided by the temperature, which is in Kelvin already, so that's perfect. So 400 minus 0. Okay, so work that out. So 80. Okay, so I get tiny answer. I get 2 times 10 to the negative 7. Okay, then if I'm using my gradient to work something out, so now they're saying use the gradient to work out number of moles if the pressure is 100 kilopascals. Just be careful, don't like pick a random value on the graph and then work out, plug in the volume, plug in the temperature, literally use the gradient because they're telling you use the gradient. Okay, so we will go V over T, okay, which is this 2 times 10 to the negative 7 is equal to N R over P. So into P's place, you'll substitute that 100 times 1,000, because at the moment it's in kilopascal. Into R's place, you'll substitute 8,31. Okay. And then cross multiply. So 2 times 10 to the negative 7 multiplied by 100,000 is equal to N. Okay, get rid of the 8,31 by dividing by it. Okay, I'm just going to work that out quickly. And I get 2,4 times 4,1 times 10 to the negative 3 mole. Okay, just shout if that doesn't make sense to you all. Okay, so we took the gradient, we substituted there, and then we literally worked out the number of moles. Just careful with this. Honestly, I find the most common mistakes probably not converting to the correct SI unit for any of the formula, the general formula and the ideal gas formula. Does that make sense?
Ma'am, I just use the normal mathematics gradient formula of y minus y2 over x1 minus x2.
Okay.
And then I got a gradient of 0,2, and my mole eventually just worked out as 2,41 without the times 10 minus 3.
Yeah. Okay, so I think just
the same.
Yeah, just be careful because it's technically it's in centimeters cubed at the moment. I'm just kind of looking over the memos already to see if they will accept that. Okay. No. Okay, so you'll have to convert this to meters cubed. You'll have to convert the volume to meters cubed. You know what? Because you're using this formula, and whenever you're using this formula, you have to have your volume in meters cubed.
Okay.
You're not
Thanks,
you're not wrong in terms of working out the gradient, but because you're going to plug that gradient into this formula eventually, your volume has to be in meters cubed.
Okay, thanks, ma'am.